This elastic electron scattering experiment takes place inside a vacuum chamber, which is pumped with a turbomolecular pump to a typical background pressure, leaving no gas inside the chamber. The setup's materials include an electron gun, a single gas needle, and a detection system with a channeltron, which will make up this crossbeam apparatus that will obtain scattering intensities. This collision of particles is based on a crossbeam technique where an incident electron beam is emitted from an electron gun and an atomic molecular beam of methane gas molecules is emitted from the stainless steel gas needle. An elastic electron scattering reaction will occur when the incident electrons collide with this molecular beam perpendicularly with the crossbeam setting. By thermionic emission, incident electrons are derived from the cathode of the electron gun, or the hairpin tungsten filament. 7 electrodes of the electron gun extract and focus the electron beam into the interaction volume, or the detection system where the interactions will occur when the beam strikes the sample surface. Simultaneously, the beam of methane gas molecules is being emitted from the 40 mm long gas needle with a diameter of 0.5 mm. After the interaction with the molecular beam, scattered electrons enter the detection system. Cross-sections for elastic methane electron scattering in the 50 to 300 electron volt incident electron energy range are produced, measured, and calculated. The reported results will act as a reliable standard for similar future studies.